Professor, parece que a gente está indo. Sim.
Ok, vamos reiniciando então. Boa tarde a todos e todas que estão participando desta apresentação, a defesa de mestrado do programa de pós-graduação em Oceanografia da Universidade Federal de Santa Catarina. Hoje teremos a apresentação do aluno Wilson Galvão, vai defender então seu trabalho sobre a evolução geológica da Baía da Babitonga. Antes de passar a palavra, então, para o Wilson, né, para ele fazer a sua apresentação, eu gostaria de agradecer, então, à banca, né, pela disponibilidade e tempo para revisar o trabalho, e a professora Carla, então, Bonetti, do nosso programa de pós-graduação de Oceanografia, da UFSC, ao professor Guilherme Lessa, da Universidade Federal da Bahia, né, do grupo de Oceanografia, e ao professor Christopher Hein, do Instituto de Ciências do Mar da Virgínia. Já deixo também meus agradecimentos, né, todo o apoio de desenvolvimento do projeto, do Wilson, né, ao professor Michel Maix, do Instituto Oceanográfico da USP. Wilson, você vai ter 30 minutos para fazer a apresentação, e depois a banca, então, tem até 40 minutos cada um, né? Então, 20 minutos de perguntas, 20 de respostas, para fazer a sua arguição. Aí, ao final, então, nós paramos a transmissão e fazemos, então, uma reunião só entre a banca para, então, fazer a sua avaliação, tá? Antes de você começar, eu vou fazer uma pequena introdução em inglês aqui, né, para o Cris poder, então, entender.
Klein, posso te interromper só um pouquinho? Desculpa, mas parece que não tá passando no YouTube. O que você acha de gravar também por aqui? Você tem habilitação para gravar essa sessão aqui pela RNP? E se der errado o YouTube, a gente tem essa sessão gravada?
Por algum motivo, o sistema está dizendo que eu não tenho permissão para gravar.
Ah, meu Deus.
Hoje
Olha,
tudo...
nunca aconteceu tanta coisa. Eu participei de 3 bancas essa semana e nada deu errado.
Pois
Hoje, realmente... Porque eu não sei, eu não estou conseguindo acessar o YouTube. Não começou, não está passando nada lá ainda.
Professora, se você atualizar a página, eu acho que funciona, porque a Laís que está aqui junto, ela disse que está
Estão
conseguindo
assistindo?
Uhum.
Então tá, desculpa. Então tá, porque aqui para mim não passa, mas se tá passando, desculpa, então.
Obrigado.
Ok, Carlos. Parece que está funcionando no YouTube.
Sim, então, desculpa, foi aqui então o problema.
Bom. Fazer uma pequena introdução, então. Good afternoon, everybody. Today we will have the Master Thesis Defense presentation of Wilson Galvão. He will present us his thesis about Babitonga Bay evolution. And he will have 30 minutes for this. Then we're going to have the evaluation of the committee. First of all, I would like to thank Professor Carla Bonetti from our program, and Professor Guilherme Lessa from Federal University of Bahia, and Professor Hein from VIMS, Virginia Institute of Marine Science, to be part of this committee. And thanks as well for Professor Michel Maix for helping us during the this project development. As I said, Wilson will have 30 minutes for presentation, and then we'll have the evaluation. Okay? Well, you can start. A palavra é sua, Wilson.
Okay. Hello, everyone. as Professor Klein said, I'm Wilson, and the title of this presentation is Geological Evolution of Babitonga Bay, Santa Catarina, during the late Holocene and during the late Pleistocene in Holocene. Here I have a summary of the presentation. We'll pass by the motivation, the study area, the objective of the study, the methodology, the results, and the conclusions that we can. So the motivation of this work is based in the morphological changes that occur in the coast due to increase or decrease in the accommodation space that is a function of sea level change. So as the sea level rise, this space of accommodation may increase, and the strand plane or the delta that may be in the coast can become a estuary or a lagoon environment, as Boyd has presented. For us in Brazil, we had a transgressive pattern of the sea level that was rising from the last 20,000 years ago until about 5 years ago, and it starts to fall until reach nowadays level. As the literature shows. So this site is Babitonga Bay. Babitonga Bay is located in the south of Brazil, in the northern coast of Santa Catarina. Babitonga Bay is a story developed under a longshore-oriented Graben's coast. This coast, this story is over a tectonic valley that we have here. Here's Babitonga, and its maximum length it's about 20 kilometers. Its maximum width is about 5 kilometers, and it has about 160 square kilometers of area. Also, here we have a more detailed description of the study site, where we have the main channel, the Palmertown channel, and the Lingual channel, all of them combined together to define the Babitonga Bay. So in Babitonga Bay, we have the delta, the flood delta, the ebb delta, the ebb delta and the flood delta over here, and some tidal banks, and this coast is a coast that is wave dominant, with so the hydrodynamic in the mouth of the Babitonga Bay is dominated by waves, and the inner part of the bay is dominated by tides. And we have a northward along coast transport, along shore transport, and as I have said previously, the sea level for this coast has a transgressive pattern from 20,000 years ago until 5,000 years ago, and then it starts to fall to nowadays level. So the objective of this work is to describe and understand the stratigraphic architecture of Babitonga Bay and propose its evolutionary model through high-resolution data supported by sedimentary cores. For this, we aimed to correlate the seismic and sedimentary units to establish the stratigraphy of the bay, describe the extent and morphology of late Pleistocene and Holocene transgressive and regressive deposits, as well as rebuild the feeling of the available accommodation space in the tectonic estuary that we call Babitonga Bay. So for this study, we used two main data. We have used seismic data and vibrocore data. Starting with the seismic data, was used about 2,280 kilometers of 2D seismic sections over the bay. For its processing was used a velocity of sound of 1,060 meters per second in sediment, and in water was the velocity used was 1,500 meters per second. For the filtering of the data was used the bandpass filter with a frequency window of 700 and 1,200 hertz, and the processing in the unconformities in the seismic sections was done in EG's environment, and the interpretation of the seismic phases was done by analysis of internal reflections and lateral contacts. So we have this flow chart for the seismic processing over here. And here we have the processing of the sedimentary data, starting with the subsample of the samples. We used 5 sample locals with collection in pairs of the cores. The cores range from 160 meters to 300. When the longer cores were used for analysis of granulometry and hydrocarbon analysis, while the shorter cores were used for geographical properties. The hydrocarbon and the geophysical properties of the sediment was done by collaborators. The hydrocarbon was run in the Woods Hole, and the petrophysical properties was done in the UFSC. So, starting with the results from the seismic data, we have 6 main unconformities that define 2 subunits and 4 main units along the rock basement and some shallow gas features. Here we have the distribution of these reflectors and their thickness over here, the depth of occurrence actually. And here we have some examples. The first reflection of all is the R1 here, and so on. We have the rock basement over here, and these 2 seismic sections are from these locations inside of the bay. So the course results, we have a lot of parameters for analysis, starting by the the code logger, which was done by the analysis of sediment in the field, and was also supported by the granulometric analysis in the lab. And also we have the petrophysical properties of such material. The geophysical properties are the sound velocity of the waves, the gamma ray density, which is related to the density of the material, the natural gamma ray parameter that is related to the radiation of the sediment, and it's a proxy from moody sediments. We have also the magnetic susceptibility, which is related to magnetic minerals, and the resistivity of the material, which is related to the porosity of the sedimentary column. So with this, along with these parameters, we had the radiocarbon analysis, and then with all of this data, we defined the sedimentary units. So we have unit U2, U3, and 4 over here, 3 units. And in this sedimentary cores that we have a span of less than 2,000 years until almost 7,000 years old samples, which is over here. So along with the seismic unconformities and the units, the sedimentary units, we have the correlation over here. As you can see, in red we have unit 4, in yellow unit 3, and in green we have unit 2. So each sedimentary unit is related to seismic unit. Such examples over here are positioned in these parts of the bay, which is the sites of our samples. So we have 3 correlation. We have the units 2, 3, and 4 sedimentary units being correlated to seismic units, and with it we could identify about 9 seismic facies along shallow gas features and the rock basement. So the most part of these deposits were occurred in a transgressive system tract, and only the newest one was deposited in a high system tract. So I will detail them now. Here we have the rock basement facies, which does not present internal reflections, only the multiples. This is an example of this part of the study area, and again, this is the distribution of this reflection. We have also shallow gas features, 4 types of them, as the acoustic turbidity in green, the acoustic blanking in orange. We have also black shadows and intrasedimentary plumes. The difference between them is the compartment of the gas in the sediment. When the acoustic blanking and black shadow, the gas is mainly trapped. In acoustic turbidity, situations, the gas it's escaping, almost escaping, and in intersedimentary plume, the gas is migrating along the sedimentary column. Also here we have the distribution of the acoustic blanking and acoustic turbidity, which represents about 99% of the occurrence of gas. So starting with the seismic phases of the deposits, we have the seismic phase 1, which is mainly a transparent fill of the unit U0. This unit we couldn't interpret it because we does not have internal reflections, probably due to signal loss. The next one is the seismic phase 2, which represents the central basin, as illustrated over here. This unit presents some low frequency reflectors with low or medium amplitude and subparallel to chaotic reflectors. Next, we have seismic phase 3. This phase occurs in units 2 and 3 and presents some internal reflections with low to high amplitude and frequency, high dive angle, as you can see, with or some sigmoidal or oblique tangential clinoforms. Such phases represents the Bayhead Delta, or environments of prograding banks, as well as tidal banks or tidal flats. This seismic profile is here in Guadalajara. Next, we have seismic phase 4. Seismic phase 4 occurs in units, the subunits 1.5 and 2.5. This phase presents medium to high amplitude and frequency, with parallel or concave reflectors that have a infilling pattern of gradation. This phase is interpreted as low course river channels, lateral migration, some point bars, and maybe meandering channels. This section over here is located in this part of the bay. Next, we have barrier systems identified in the inner shelf. This phase 5 occurs in the unit 1, 2, and the subunit 2.5. This phase presents low, medium, or high amplitude, some sub-horizontal reflectors, and high frequency. We have interpreted these phases as barrier environment. And this first seismic section is here, when the left is in the southwest part of the map. And this section over here is this indicated as this yellow one. The southern part of the section is over here in the right. Here we have a zoom in a migration tidal channel that is about over here. And next we have seismic phase 6. Seismic phase 6 occurs in units 3 and presents high amplitude and frequency of its reflectors, which are parallel and form clinoforms with low diving angle on seaward. And here at Itapuã coast is where we have this zoomed part, and this is the phases 6. Seismic phase 7 occurs in unit 1 and 2. 6 phase 7 presents low to medium amplitudes with low frequency upward concavities that unlap the margins of the basal unconformity. As we can see over here. Here, this is the facies of phase 7 that sometimes overlaps its basal unconformity. Sometimes this facies is transparent, and it is interpreted as linguado channel mouth, which this section is over here. Next, we have the seismic phases 8, which occurs in units 1, 2, and 3. This phases presents transparent field pattern, or sometimes with low amplitude and low frequency when the reflectors are present. When present, these reflectors has parallel or upconcave reflectors that builds a divergent pattern, as you can see over here. Sometimes they are parallel, sometimes they are concave. Such phases is interpreted as flood and ebb tidal deltas. The section over here is across the mouth of Tonga Bay in the main channel, and this section is the section over here in the inner shelf. Finally, we have the seismic phases 9. This phases occurs only in the unit 4 and presents high amplitude and high frequency of its reflectors. And these reflectors occurs parallel and have high continuity. They have high continuity. The interpretation of this phases, they present sedimentation in the bay, which sometimes presents some bed forms that occurs in the bottom of the channel, and the hydrodynamic is sufficient to build these bed forms. So with all of these phases, we have a synthesis with 2 profiles inside Tonga Bay. We have a profile that cuts through Saguaçu Lagoon in the inland and until the inner shelf, which is this profile, this black profile along the main chain, is this first profile. And we have also a profile that goes from palmital channel until the lingual channel. It's the above one. So in this profile, we have a lot of interpretation, but it's mainly built by Bayhead Delta deposits and its channels, sometimes as pilot channels or actual tidal channels. In the main portion of the main channel, we have a high frequency of the rock basement occurring, and in various parts this rock basement outcrops in the floor of the bay, and in the inner shelf we have facies of deltaic environment. We have as well as back Bahir Lagoon in the seaward portion over here. Here below, in the profile that goes from palmital to linguado channels, the main deposits are built by Bayhead Delta deposits with its pilot channels, and we have some presence of gas, as we can see here in green, and also have some tidal banks above the Bayhead Delta in this part. So all of these interpretations lead us to our evolutionary model. The main units that we found, which are the unit 1, 2, 3, and 4, was plotted in the seismic level variation curve. So the units 1, 2, and 3 was deposited in a transgressive system tract. And in this period, we have Babitonga Bay segmented in 4 systems. We have system 1, which is mainly a estuarine system. System 2, which is also a estuarine system. We have system 3, which is a lagunar system, and system 4, that is a coastal system. Here we have the evolution of the bay, and starting with unit 1, we had a bay was sheltered by a barrier in the inner shelf that sheltered Back Barrier Lagoon. We had, as I said, a lagunar depositional system that was separated by the estuaries by the basement that was exposed in this elevation of the sea level. Next, we have unit 2. Unit 2 seems to be alike unit 1, but now we have rollover process of the whole estuary into the mainland. So the deltas was migrating landward as well as the barriers, and we have some washover fans occurring now. And this, in unit 3, this kind of environment is actually very different. In this moment, the barrier was almost drowned or was eroded. We have some barrier islands along San Francisco Island, and in the portion of in front of Tapua Coast, the barrier was mainly eroded or was welded in the coast when it migrated and reached this portion over here. Also, we have some inlets that connects the back barrier with the inner shelf, and in this moment is when we have the whole bay united in one system, when the sea was about 5 meters above the present one. So Babitonga Bay was established, completely established in this part, with 2 connections with the sea, in the main channel and in the Linguado channel. Finally, we have the last unit. This unit was developed in a high stand system tract, and it's in this moment that we have the development of our present strength plan. We have regressive strength plan built in Itapua. We have a field of Back Barrier Lagoon that today is resumed to only this little lagoon, which is the Acaraí Lagoon in São Francisco do Sul. Also, we have the development of Capri sand spit inside Babitonga Bay due to a longshore transport of sediment that built built some sand spits along the whole shore in front of some channels. So for the conclusion of this work, we have 2D seismic and vibrator data that enabled the investigation of the rock basement that shapes the valley, as well as the late Pleistocene and Holocene stratigraphy of Babitonga Bay. Also, we have 5 seismic stratigraph units that was units 0, 1, 2, 3, and 4, with 3 young units being correlated in the sedimentary units. Also, we have found fluvial, estuarine, and coastal deposits. And the stratigraphic interpretation gives us insights in the evolution of the estuarine systems inside Babitonga Bay and its inner shelf, as I have presented. So here we have 5 topics that I have already talked about. That Babitonga Bay was segmented into tectonic valleys. The Paleo-Barrier system along San Francisco do Sul Island and the Tapua Coast was preserved by rollover and overstepping process that occurring in rising sea level. Also, we have the Back Barrier Lagoon overstepping process removing the trapping the sediment in the inner shelf that could be built a bigger strength plan in next to the main channel of Babitonga Bay. And the two valley was amalgamate in a single estuarine body when sea level was rising. And we have also the development of the strength plane with the sea level falling to nowadays level. And this is it. Professor?
Yeah, I'm here.
I don't know how much time I had, so I rushed in the final part. So
okay, Wilson. You are in time.
Okay.
Okay, it's done, almost.
Thanks.
Ok. Bom, agora a gente vai passar para a parte de arguição, tá, Wilson? E depois da sua apresentação, né? Então a gente passa para a parte de arguição. E eu vou passar a palavra então para o professor Hein. Okay. Well, now we will start in the evaluation. And then I will não, você não pode parar a transmissão, tá? A transmissão tem que continuar durante a arguição, Wilson. Okay. Now we will start the evaluation process, and I will ask for Professor Hein to open the camera if it's possible. And please, it's your time.
Thank you very much. Klein, just to make sure I am clear, so I'm going to start my clock. Exactly how much time do I have? Is it 20 minutes? It's 20 minutes?
No. You can, in total it's 40 minutes. Okay?
Okay.
You can do 20 minutes question, then Wilson can answer you 20 minutes, or you can just you do a question and then he answers, but in total the time is 40.
Okay, 40 minutes. Okay, and all right. We'll see if I torture you for that long, Wilson.
Thanks.
That's intense. First of all, since I have 20 minutes to speak, I want to start by saying thank you very much for including me in the project. Thank you for including me on your committee. And thank you very much for an excellent body of work and a really great presentation. I would not, let's just say you'll never see me give a talk in Portuguese. And so I am very grateful for your doing this, doing so in English. Maybe that's the requirements, but obviously it allows me to participate as well. So I do want to thank you for that. I also want to say congratulations on an enormous volume of work. I've done a bit of the seismic interpretation. I know that the processing and all the interpretation, many long nights in the dark with the computer and a beer, click, 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 tracing. I don't know, maybe the automatic tracers have gotten better, but I know how painful that is. So I want to say congratulations on that and a really nice looking thesis as well. I look forward to seeing it in publication. So all very, very good. So very impressed with your effort, Wilson. So thank you across the board. Okay, so the questions. My questions are kind of a little bit all over the place, and I will say that this being a defense, I like to think a little bit broad and see where your head is. I'm not going to get hung up on details of your interpretations. I commented on those in the document that I sent you in places, asking about dates and stuff. I want to think a little bit bigger here, if you don't mind. So first, as I was telling Mahix a little while ago, I'm going to teach a class on across in the UK, and I've been spending all week. This is the only time this week that my brain has been in the Holocene, because I've been thinking about the bedrock geology of the UK, which means I've been thinking a lot about the more than half a billion year history of that area. And so the first thing that came to mind watching your presentation and all the discussions of the bedrock controls of accommodation here is, why is Babatonga Bay there? Why is there that low area? What is the origin of the bay, geologically speaking? Pre-Pleistocene, pre-Quaternary? My guess is that it's probably, I don't even know when. Do you know? And it's okay if that's not an easy, and because I know that's not something that was in your world of study. But I look at that coast and I say, well, there's a large estuary, a big hole. Why is it there?
Recently, in this year, I passed through a paper that was discussing about the tectonic valleys, using Babatonga Bay as a model, and they suggest that we had the new neogenic activity of tectonics that builds the gravens over there. And so inside these gravens, Babatonga Bay seems to be developed. Also in the strand plan, in the smaller estuary at north, that we have Guaratuba Bay. The literature says that it's almost infill estuary, starting that keeps its estuary body due to tide energy that keeps the channel there, so it's not infilled because of the channel, the tidal current. So probably Babatonga Bay is a lower basin in the tectonic valley in the whole coast over there, just like Paranaguá, which is a larger, even larger estuary. But
and its mouth has a very similar morphology, doesn't it? I mean, now that you say that, you make that connection. I remember the first time I looked at Babatonga Bay, I thought from a distance there was like a hand drawing, and I thought, oh, that must be
just like we have here.
Yeah, it's got some similarities to it. Yeah,
yeah.
We're
gonna do a bit
channels
talking about.
Huh.
Also, all the most channels in this straight plane has the same orientation of the coast in São Francisco do Sul Island, which is just like this line that I'm drawing over here. Most of them converge until almost the coast, or they come in the drainage of this estuary.
Thanks. I'll let, if others want to pick up further on that, they can, of course. But I think for me, that as we say, that scratched the itch. That answered the question that I had and helps me understand it a lot better. So thank you for that. The bedrocks still. I'm still on bedrock though. And I think that's one of the more interesting findings that I'm not sure I respected as much when I read your thesis as when you gave your presentation. You really stressed it a lot more. The idea that the bedrock at a not very lower, late Pleistocene, even early Holocene sea level, the bedrock was stopped what's now the main channel. That did not exist because it was blocked by shallow bedrock. So I think that's a really fascinating question as you posed it about accommodation. I guess I'm just kind of, and so I was trying, I guess when you were talking about the later stages, there's this switch where all of a sudden that bedrock gets flooded, and now what is now the main channel, the one that runs to the east northeast, becomes the main channel. I remember that it's humans that filled in the southern channel. But I'm curious for your thoughts now. We think a lot in the coastal processes about how there are interactions between what's happening at the outer coast, in this case, at the beaches and barrier islands, in your penultimate stage, and what's happening in the back barriers, in this case would be the estuary. So do you think, or could you speak to, so you've got so if there's there's 4 stages there. So the third one is where the main channel opens up. So I guess my question is, I get that then takes over most of the flow in the channel, but how do you think that might have changed the hydrodynamics, the wave energy, the maybe even the tidal flow, sediment transport patterns, you name it, any of these things along the front of the coast?
Yes.
Sorry, I have to work from home today. Someone's at my door, but I'm going to ignore them. So sorry about the noise, but go ahead.
Oh, sorry. Okay. Actually, could you repeat your
Yeah, of course. So I don't see a way that I can draw, but in your third panel there, that the one that's circled in red right now.
Yes.
That stage. That's the first time that you have an opening through what's now the main channel.
Actually, here I presented the maximum fluid of the bedrock, so which is about 5 meters above today.
Okay.
So probably when it connected, the channels was connected, it was different, but in some moment the width of channel have allowed the catchment in the main channel be bigger than the previous one.
Yep.
Like,
And I guess that's the time period.
sorry.
That's the time period that I've got that really is that I'm questioning or that I'm curious about. What happens to the coast at that point? Like, do you think that there's changes in how waves or tides or currents or sediment are moving outside? Yeah. So once you have that, and all of a sudden you start to get this huge flow through this newly flooded channel, how does that change what's happening?
Probably
out on the surface?
We had a strong hydraulic barrier over here when we had the ebb tide delta today.
Yep.
That actually this hydrological barrier makes sense when we see the form of the present delta. That's something in the shadow of the along shore transport. And this, sorry, I don't know, maybe the orientation of the strength plan in São Francisco do Sul reflects the where I'm sorry. This over here reflects the diffraction of waves that probably was diffraction in this.
Yeah. That's a good thought. Yeah, that makes sense. So that's a much larger ebb tidal delta.
Yeah.
Before the main channel opens up.
Yeah.
So you're definitely changing wave refraction patterns out on the coast.
Yeah.
That's a really interesting thought.
Probably that's the motive of this partial does not present some barrier remnants, just like here we have some.
That's really interesting. Thanks. Yeah, that I hadn't even thought about that. And questions like this, by the way, I do not know the answer to. I am asking because I'm curious for your thoughts, because you have spent a lot more time thinking about this site and studying this than I have. So that's a really fascinating one, because when we look at, say, strand planes, we often think about the allogenic controls. Maybe waves changed. I mean, the last student's thesis I was on was Anna Polidasova. And she was looking at large global scale changes in weight. I'm alone.
Yeah.
Did I lose you, Wilson? Are you there?
Yes.
Oh, okay. I lost your video. So I'm just looking at myself.
Okay.
Okay. So I was looking at I'm thinking about Anna's study, and there she relates everything to, this large global changes. And here you have a very neat example of an autogenic change. Something changed within the system, which maybe, you lose this large ebb tidal delta in front of that southern channel when you create the main channel, and that really shifts the way it goes. And that's exactly the kind of thing I was hoping you would comment on. So thank you. That's very neat.
Wilson, turn on your camera, please.
If I saw he was
turn it off.
Turn one.
Someone. Actually, I can't close this window over here because we are transmitting our presentation. When I have closed this window, our streaming have finished. So for me to turn on over here, I need. Okay, I'm here.
Okay. Okay, so let's think about that was kind of the past. Those questions were about the very deep geologic past, and then the more recent that was involved in your study.
Yes.
I have a question about the future now. So
Okay.
you couched, and this again, it's open-ended because I like in these defenses to see how you as a student are thinking through all this. And so maybe this is not traditional. It's pretty common in the way we do it here. So if it's different, sorry. That's what you get for having an American. So one of the things, you pitched your whole study in the context of accommodation and sea level rise, which is logical. You have got these accommodation changes are huge, or the available accommodation because of the bedrock is a huge control. So this is an estuary, which means it's infilling from both sides. It's in probably. So I guess based on your studies and all your data, what is the future for Babatonga Bay? I know that it is, there's squeeze along the coast. But what about the main bay itself?
Right.
Is it infilling?
Could you repeat, please?
Yeah. So what is the future of the main part of Babatonga Bay? Is it going to infill faster than sea level rise, or will it get deeper with time?
Actually, we need to some sedimentary data to think about it. But if you are going to think that we have permanent sedimentary rates of sediment coming, I would say that Batonga will first flood the mangroves areas. So maybe if we are talking about high sea level, probably it will be coming backwards to this moment here. And
We have to answer again because the internet just fell.
professor, seu som tá no
Wilson, you hear me?
Yes.
You have to answer again, Chris, Professor Hein, because the internet just fell.
I was able to understand so far, but it is very broken. And Klein, you two are broken up.
Yeah.
Yeah. Everyone is hearing now?
No. Klein, if it's okay, maybe with the video off, I'm okay with that.
It's okay.
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 I made sure I did my hair nicely, so I don't care looking at myself today.
Okay.
Good. Actually, Professor Hein,
Better.
you're doing better now?
Yes.
Actually, I was talking about the changes in the way, considering
Nope.
high.
We're breaking up again. I'll turn off mine too. I don't think that's the problem though.
Try again, Wilson.
Professor, are you hearing me?
A little bit. It's better, but it's not great, unfortunately.
Okay. I was considering rising sea level. Probably we'll have and also constant sedimentation rate. We probably will see the flooding of the plains in the mangrove area, and maybe some tides will reach some parts that first was not reaching, and maybe could erode something in the main channel or in the, probably not in the main channel, but in the inner part of the estuary. So maybe you have some reworking of sediment or some loss of sediment and something like it. But firstly, the main scenario is the mangrove area that are like plains to be flooded and high tide events.
So, okay, and one of the things you said there, yeah, that makes a lot of sense that you're going to have this flooding of the mangroves in the area. I agree with that. One part of your answer gave me another question. Sorry.
Okay.
And that is, you said assuming constant sedimentation.
Yes.
And yeah, thus far, sea level is rising slowly, but is going to accelerate. And if sedimentation remains constant, then the bay will get deeper and wider, of course.
Yes.
Is there any reason to think that sedimentation might change in the future? I'm thinking about climate or, the river system.
Yes. The area is a local that has a lot of rain in the year. So if the pattern does not change, probably our sedimentation rate may change because of erosion. Like if we lose some muddy sediment, again we can have the change in the banks instead of the bay, or we can deepen the channel of these banks that could not change. And maybe our land speed over here, Sarah have worked on, may change. I don't know. Yeah. He's built it in the area of the flood tide, so probably it could reach a larger land inside Bactonga.
Yep.
Maybe the Itapuacos can change something with high tides. We have also more energy in the ebb tides too. So,
yeah. So thank you. I mean, those are good thoughts. I think I don't know what your plans are next, but I know a lot of students now in coastal science do go on to work in more management and policy fields. And I think if I were working with a manager, if I say am a government official in in on San Francisco Island, I'd want to know. Those are the questions I would be asking. So what's going to happen now that sea level is rising faster to the bay and to the coastal system? So yeah, it's good thoughts. Thank you. Okay. Another question I'd like to ask, and that I think this lends itself very well to, can you go to your data collection in one of your maps showing all your data collection sites?
Yes. We're here.
Yes. Yeah. I like that in the lower right corner there. So if you, all right, now you've completed the study. And if you could go back, you were a student, you did not get to design this study, but if you could go back and do it all over again.
Yes.
Would you core in the same places? And where would you core? Let's say you knew you could take those 5 cores and they would be just as long or short as they were. Would you, where is that place that you really wish, I would have gotten rid of that this core, but I really wish I had a core here.
Okay. First, we need to say something about the coring, which was limited by the column water. If we do not have this limitation, probably I will be coring over here.
Okay.
When we have the fluid tidal delta, because here it does not have enough depth to navigate and invest and do some investigation about the sedimentation. Also, if we do not have the column water problems, something in our overstepped bear here, over here, I don't know, something. And okay, here would be, we have clear interpretation, but would be nice too.
Yeah.
And of course, something in this bank and in this portion over here in front of the channels, because we could see some doubts that we have about the core A1 that have a bottle sediment different than expected. And over here we had the right sedimentation rate.
Yeah,
That's
right.
about 2 point something. Very different from the other ones. And all in the last unit, which is unit 4.
Yeah, I mean, so certainly, I mean, okay, so we have you and I have somewhat different interests, maybe overall. For me, one of the, I mean, and I agree with all those. My most, thing I would want to see the most is the core through the drown barrier. I agree, that's my favorite. But I think a lot of your other arguments make good sense here. And wouldn't it be nice if we didn't have the data that didn't make sense to us? The really fast accretion, that would be a core I would give up. But we have the data that we have.
Yes.
So an extension of that question is then, what about the seismic? Or let me ask it a different way. If I said, hey, Wilson, stick around, here's 200,000 reais to go do more work, what would you prioritize? What would you say, I really would love to get, maybe it's more seismic. We know what cores. Maybe it's a different type of method that you did not apply here. I'm curious, what would you do?
There's something there that I think would be nice too. Something, it could be more, I guess, resolutive data to investigate the unit 0. We do not have any signal. The whole unit is transparent, so some things that goes deeper would be nice. Actually, I was thinking about it too. Radiocarbon in this unit would be nice too. We are assuming it to be placed the sample, but where in the same, so it would be nice. And still with deeper range of signal along the coast, maybe to study how it was when the catchment was mainly of this part. The mainland was in this section, system 1, that was separated of this part. So probably we have here, pilot chamber here and here, and something maybe has changed. So something like it.
you've done without those data. You've told a very nice story, so I congratulate you for that again. But yeah, I agree. That would be really fun to have a bit more in those places. I'm fascinated by what this could have looked like when you had that bedrock sill blocking the channel and trying to reconstruct that. So that's great. All right, you know what? I'm going to stop there. I know I don't have to take the full time, so I will not.
Okay.
And I will say thank you for answering my questions and putting up with them. And yeah, and again, congratulations on a nice job. And I know I'll turn, I guess, to Antonio, who I guess maybe will take a break.
Okay. Thanks, Chris. Thanks for the thought about it. Maybe we'll talk later.
Indeed, you know where to find me.
Okay.
Okay, Professor Hein, thank you very much for your great evaluation, great discussion, and you give us a holistic overview of the Bay evolution. Yeah. Okay, we're gonna have a 5-minute break, and then we'll come back to continue the evaluation. Ok?
Ok.
A gente vai ter, então, vamos fazer uns 5 minutos de intervalo, e daí nós retornamos para a avaliação, aí com a palavra do professor Guilherme e, posteriormente, da professora Carla. Ok?
Ok.
Pode deixar ligado o sistema aí só na tela, só desliga o microfone. Wilson, podemos retornar?
Yes.
Ok. Mantenha compartilhando a tua tela. Guilherme, você se encontra aí?
Ok, Klein.
Ok. Então, eu passo a palavra para você, então, Guilherme.
Ok.
Vamos ver se a internet colabora conosco. Está difícil hoje.
Vários problemas.
Ok, compartilhando aqui. Ok, Wilson. Prazer vê-lo de novo depois de não sei quantos anos do nosso último encontro em Florianópolis, né?
Tem tempo, foi em 2019.
Bom, eu vou interagir inicialmente contigo.
Professor, só um momentinho. Eu vou pedir para ele desligar o vídeo, porque voltou a pular aqui o som. Pelo menos eu vou desligar. Se continuar, daí eu falo para você.
Ok. I'll make some introduction here in Portuguese and I'll switch back to English so Chris can interact with us a little bit later. Mas então, Wilson, bom, fiquei feliz de poder ter acompanhado aí todo o processo de desenvolvimento do trabalho. Tá? Houve um significativo progresso, né, desde a primeira vez que nós conversamos há 1 ano atrás. A pandemia aí interrompeu, né, atrapalhou bastante o processo, delongou bastante. E queria agradecer a você, a Klein, né, e ao Michel por terem aí me mantido até a reta final, né, com a colaboração aí finalmente na defesa. Eu, assim como o Christopher falou, você tem um apanhado de dados aí magnífico. Tá? O que você tem de dados e até mesmo a profundidade das suas análises vão bem além daquilo que se espera de uma dissertação de mestrado. Tá? Então, lhe dou os parabéns, assim como aos orientadores e co-orientador, né, por esse magnífico trabalho, né, de análise e obtenção de dados. O que quisera eu, né, o que quiséramos nós, que a gente tivesse essa quantidade de informações, né, para mais locais no Brasil. Né, mais estuários brasileiros, né? Sem dúvida nenhuma, a Babitonga é a baía mais bem investigada do ponto de vista morfoestratigráfico nesse momento. E que sirva de modelo, né, para estudos aí por vir. Com relação às questões, eu queria saber inicialmente, Wilson, se houve algum tipo de modificação nessa sua apresentação final em relação aos questionamentos que foram feitos por mim, Carla e Christopher, naquele momento anterior da correção da redação.
Sim. O que aconteceu? Teve, só que a gente considerou que seria um trabalho muito grande reenviar para vocês lerem outra vez. Aí, mas eu posso te mostrar aqui o que foi mudado. Principalmente, aqui, o professor tinha apontado essa turfa que eu tinha...
Você não está compartilhando a tela, Wilson.
Opa, desculpa. Tá. Bom, voltando. Eu fiz algumas mudanças...
Só um instantinho, Wilson. Christopher, I asked him if there was any change to the presentation today in relation to what we have pointed out during the examination of the written document.
Yes.
Okay, Wilson.
Tá.
Thank you, by the way.
Eu fiz algumas mudanças, sim. As que eram rápidas de ser feitas foram feitas. Mas, sim, foi baseado em motivos corretos, né? Não foi só mudar. Bom, por exemplo, aqui o professor tinha apontado uma diferença na granulometria, mas na verdade foi equívoco meu. Na planilha lá estava um material só. Mas, por exemplo, a escala em fio eu já não consegui colocar. Na verdade, dava para colocar, mas como eu estava com o tempo apertado, eu escolhi deixar isso passar. O que mais? Nessa tabela aqui, professor, o que eu tinha tentado apresentar no trabalho que eu mandei para vocês é que o trato de sistema que determinado ambiente poderia estar acontecendo, aquela fase, era o que estava aqui. Por exemplo, a gente tem depósitos de deltas, tanto em mar alto como em transversível, no trato de sistema. Só que daí ficou meio confuso, né? Aí, entendendo a sua dúvida, eu acabei deixando para interpretação do tipo assim, esse tipo de face desse ambiente foi deposicionado nesse trato. Aí agora ficou diferente. O que mais? Essas eram as dúvidas, as questões suas mais... e tem essa aqui que o professor também falou, né? Essa figura. Aqui o que eu mexi foi baseado no que eu te falei ali atrás naquela tabela. Aí talvez eu só mexi em alguma coisa em forma de apresentar, não de interpretação.
Sim.
Coloquei, por exemplo, coloquei aqui as escalas, o professor pediu, algumas coisas assim, de apresentação do dado.
Tá, então, com relação principalmente àquela... Eu posso falar inglês, Wilson, tudo bem? Você pode até responder em português depois para ficar mais fluido. Okay, in relation to that figure where you had the cores, you just showed it. Yes, one before, yeah, okay, number A. Okay, you had that the deepest deposit, which is in dark gray. You mentioned, can you point it out with your mouse?
Okay, this one.
Okay, yes. So I was, no, actually in E, sorry.
Yeah. Okay, here?
Okay. One of the things I asked, and I don't know the answer, that's why I'm asking again,
okay,
is you didn't mention anything about a regressive system tract. Okay, since you are in a valley, it's expected that some old fluvial deposit might underlay whatever recent deposit might be. And in that deepest section of the core, you have these coarser sediments, and it's described as as sedimentologically immature. It has mica, it's not well selected, and it is older than 7,000 years.
Yeah.
So my question is, could it be part of a regressive system tract or even a flooding surface?
Responde por quê? Essa face aqui na sísmica e junto com esse sedimento imaturo, como o professor falou, ele foi interpretado como um um depósito de delta de maré, banco de maré. Ele está, inclusive, aqui, ó, é esse mesmo banco, é esse mesmo edição. Só que, bom, aqui ele está aqui e no testemunho ele está na sísmica do lado, aqui, mais para a esquerda. Ele está bem aqui assim, o testemunho, quase nesse cotovelo aqui. E é esse banco ele vem aqui nessa parte mais clarinha, aqui assim, como se fosse um banco ao longo do canal, né? E a parte que tem um sedimento mais imaturo, ele aqui, ó. é a parte que está desse banco que está como se estivesse migrando para dentro do canal, assim, como se fosse um banco de maré que foi programado.
So where would this immature sediment come from?
Provavelmente esse sedimento veio da Bahia, ou então talvez, na verdade, eu acho que ele pode ser uma junção, eu acho, do sedimento que chega, bom, a gente tem um sedimento com mica e um pouco de matéria orgânica, mas como vem de mica, parece que está relacionado com alguma coisa que não tem aporte marinho, né? Talvez alguma coisa, ou então seja um marinho que foi misturado com algum dos canais que tem aqui. A gente tem alguns canais aqui, né? Dos canais, esses canaizinhos aqui, os córregos e os rios que tem. Talvez um sedimento marinho ou um sedimento aqui das planícies costeiras aqui que foram desenvolvidas no Pleistoceno, que foi erodido e chegou aqui, alguma coisa assim. Porque a gente tem mica, provavelmente veio aqui de vazamento.
Okay, very good answer. Congratulations. So you have a lot of bedrock exposed in there and several streams coming down from this small range. Yeah, that's quite possible. And I didn't think of it. So you're giving me a very good justification for this now. And so this deposit might well be related to some sediment coming from inland or from the sea. What do you think would be the transport direction at the time where the sediment package was laid down?
Eu quero responder em inglês também.
Okay.
Tá. Probably this sediment that was sampled in this part of the area. Probably we had a reworked sediment from Pleistocene deposits of the strand plain that was over here. And with the flooding of the channel, we had some working process along some margins of these channels, and that probably these channels could have some mica, and they form this composition of the sediments. Also, we have the organic matter over here. The organic matter is when indicated by these little lips. They were mainly of root sediment, root deposits, little roots. So probably it was something that was growing in these valleys over here.
Okay,
And
but the sediment was being transported landwards or seawards?
oh, okay. Probably the sediment was the deposits of this passes is a tidal bank deposit, and as it grows, its cliniform indicates that it's growing landward here. So probably we had some high energy in this part, and in the energy in this part is probably due to appetites, because just as we have talked about the sand spit that grows over here in the fluid tide, so we have mainly the fluid tide in the lower margin of the channel and the ebb tide in the north margin. But this tides probably was increased in a fluid moment of the bay, just like Chris have.
Okay, so
Chris and I have talked about.
So this seismic information that you have, you can draw some lines in there. It's indicating that there was sediment being pushed into the bay. All right.
Yes. Yes.
Okay. So that was around 7,000 years ago, right?
About 7,000 years ago. Yes. The data
correct?
of
Okay.
our core, it's in the middle of this tidal bay.
Okay, so it was close to the maximum flooding of the bay. Is that correct?
Yes. Next to the max flooding. The max flooding was in Unit 3. Yes.
All right. And can you show now that figure you have with the sandbars or sand waves, that longitudinal profile?
This one. It's one.
All right. So which direction do they migrate?
They are migrating seaward in the talweg of the channel.
And all these sands being transported seawards, they are going to feed which kind of bed form outside the bay?
The ebb delta.
Okay. So can you go back now to your evolution model, the evolutionary model? Yes. Okay.
Mm-hmm.
So in which four of these drawings in there you have the 7,000 or 6,000 years old situation?
We have our 6 and 70 in over here, which is the Unit 3.
U3.
Something earlier than this, because this is the max fluid moment.
Okay.
No.
And I see in that drawing in there that you have a red arrow.
Yes.
Right at the entrance of the bay. What does it mean?
The red arrows means the flooding tides.
It's just the flooding tide, or indicates a direction of sediment transport?
Actually, this little bright yellow body over here should indicate the fluid delta. And here we have the development of the sand speed along at the side of the
this flood tide delta that you have drawn in there, is it inside the bay today? It is.
Yes, but the delta is something. The delta, it's over here. It just have grown.
TFD there, right?
Yes, tidal flood delta over here.
And that tidal sand bank that we were discussing a little while ago, where is it in relation to this TFD?
Actually, it is here, but it does not. It is here, since we can see in the nautical chart, but it's not. Sorry.
Would you suggest that the extension of this flood tide delta is actually larger than what you have drawn in there?
Because of our tidal bar over here.
Yeah, on the other side of the channel. You said
maybe something. Yes, maybe something with the fluid tide delta over this part. Have more attention because of Capri sand speed, but as the delta the flood tide comes for this place. Probably we have in this shadow zone of hydrodynamic shadow zone. Probably we have this tidal bar growing over here. Today this bar is present, but I didn't include it over here.
Okay.
I don't know why. Sorry.
Yeah, I could see that. So Wilson, the big, I mean, I'm trying to feed in here a little pieces of bread to make a whole package. Could you say that there was a morphodynamic change along these last 7,000 years?
Actually, just some growing of the volume of these bodies, but the position of them, it's similar. It's the same. It's just have extended, just like our strength plane, over here, or our bank that I did not have mentioned.
Okay, I'll put it in this question another way. Would you have a hydrodynamic condition today to build a flood tidal delta?
To build another one, the northern bar that is not here.
Well, are marine sand sediments being transported into the bay today?
I don't think so.
Okay, so why were they being transported 7,000 years ago?
They have drifted away in the longshore transport.
Okay.
Actually, sorry. There is sediment coming into the bay. That's it's building this morphology that we are discussing, but some part of it's being carried away.
But wouldn't the sandy sediments coming to the bay from inland would be retained in the river deltas?
They can be in the river deltas. I think they mainly first they will be retained in the dayhead deltas, in the inner part of the estuary. Just like we have a large of banks in front of Saguaçu Lagoon over here, and also in Cubatão River over here, we have a lot of sand being dredged today. So probably the sand will build some sand bodies inside of the bay first, and then come here.
But then you are saying that the estuary is not trapping sand sediments today. Is it exporting sandy sediments fed from the rivers?
Actually, this answer I can't.
So if that would be the case, that wouldn't, what you have in there as a TED, tidal ebb delta,
yes,
wouldn't be a tidal ebb delta, it would be a river delta, right?
I get what you're talking about now, but I have this kind of reflection about it, but as we have the Bayhead Delta inland, I just assume that is our tide ebb delta because it's the morphology that we found when it goes out of our estuarine body. So, but maybe it could be our pro river delta. I don't know.
Well, I'm very glad that you have pointed these flood tidal deltas with that age at the entrance of the bay, and that you agree that you have enough evidence in there to suggest that today the bay is ebb dominated. So
Yes.
there was something happened inside the bay which changed the way the tides exchange water with the ocean.
Yes.
Okay, so it has been proposed for other parts, and although it's an idea that hangs out there for, I mean, more than 2 decades, okay, there is not enough geological evidence to strengthen this hypothesis of morphodynamic changes in a geological time. And I'm very pleased that you have got something in there that can strengthen, okay, this suggestion.
Okay.
Okay, and by seeing this might have happened, it goes in line now with questions that Christopher posed to you. So what's the big perspective with this system? Okay.
Okay.
So.
So, considering that I have proposed it before, and what you have pointed now, that the Beza system that's tide dominated, probably now the first thing that I think when we have some accommodation space getting bigger is that our tides will be increased in energy, and maybe develop a bigger tide barriers over here that we have over here. I don't know, including the other things that I have mentioned before, as the erosion of mangroves as tide gauge increase and something like that. Maybe our deltas increase also, because if we have sediment being eroded in the inner part of the estuary, as the central part of the estuary, the sediment will be transported until its physical constriction and form of the channel changes in the mouth. Probably will have an increase in the tidal delta.
Well, put that in an even bigger picture. In the mid-Holocene, this estuary was sucking sand from the shore face.
Yes.
That's plausible, right?
Yes. Yes, we
Okay.
have the sand street of Capri that was
Today,
developed.
it's not sucking it anymore. It's allowing the sand to bypass. Okay, with
Yes.
all the littoral drift system is not being hijacked in front of the bay. It's allowing all the sand that's coming from the south to go past, going towards the north, right?
Yes.
So I think that's a very, very important question. Not question, actually, a very important issue, or a very important point. Okay, and I would think that it doesn't only apply to Babitonga, but it also applies to Paranaguá and Guaratuba in the north.
Yes.
These systems, they were sequestering sand from the shore face in the past. Okay, and as sedimentation moved on, mangroves were formed, the whole morphology of the bay was changed, the tidal flow was also changed, and it allowed for ebb tide currents to be stronger, and this sequestering of marine sediments stopped when this flip of the tide occurred. So all of a sudden, and that's a big question now, so how long did it take for the switch in between flood and ebb dominance of this estuary take? Because all of a sudden, it allowed a lot more sand to move up the coast. okay, and help with the progradation of the coastal plains. So at one point, you had an excess of sediment coming in from the south because sediments were not being held anymore, and it promoted the progradation of the coastal plain at a faster pace.
Yes.
Okay.
Probably we will see something that was already described in Itapuã Coast when we had some shallow tidal flats over here that was connected to the sea, and the sand spit was growing from the rock coast, and then filled some parts, and we had strength band established. Then the next one, and so on.
Yeah,
just like
exactly. That would cascade northwards.
Yes, probably that's something that have occurred with Guaratuba Bay, and I don't know, in a geological scale, something in Paranaguá will be most evident than in San Francisco and Guaratuba.
Okay, so I'm quite glad that you showed this information in there. It's thrilling. Okay, and if you are, I don't know if you have already written any paper, if you prepared any paper, or if there is still time to consider this aspect, that would have actually add a very broader perspective. Okay, to this understanding of the whole system, not only Babitonga, but this whole stretch of the coast. Okay, it's all interconnected.
Yes. Actually, we have submitted an issue that is being reviewed right now. We need to wait for the review's answer. And I don't know how it goes, but we can insert some discussion about this topic in the article, and of course you will be included in the paper. I don't know.
I have one last question, Wilson. Do you have any indication that there are stratigraphic windows in the bay, in Babitonga?
I'm sorry, I haven't think about it. Maybe if we could have the geochronology of the units U0, that we don't have any reflectors or ages or anything. We just know that there's unconformity and just it. But if that unit is the Pleistocene, it could be the Pleistocene of some of its high structured systems, but we couldn't say that it was surfaced from the lower Pleistocene or in the middle of the Pleistocene. So maybe I can just thinking in this stratigraphic window. You had something in mind?
Can you show some of those longitudinal stratigraphic profiles that you have? Okay, is there any place in there where a lower sediment unit is outcropping?
Oh, I got it. I don't think we have. All of them are kept by the last one. Just maybe here we have the unit 2.
Yeah.
That is kept by the newest one, but the depth of this deposit is some meters, so this is quite exposed. And this portion is here in the deepest portion of the Talweg.
So in other base that I have got information from, it was quite clear that there was an exposure of lower stratigraphic surface caused by recent erosion of the capping sediments,
Yes.
and that would be caused by this strengthening of the ebb tidal flows, pushing sediments away or further down the bay outside and eroding the main channel. Because as the mangroves, they grow from the sides into the center of the channel, they squeeze the flow. And so if it's possible, the flow will be, when they squeeze the flow becomes stronger. And if the sediments that caps the bottom, if they are friable, they are easily eroded. So you can have the deepening of the channel and excavation, and then lower sedimentary units, they are then exposed at the bottom.
Yes.
So that's a process that is conjugated. Okay, they occur along with this switch in the morphodynamics when the ebb flows become stronger. So I was expecting to see some of these windows in your profiles.
Yeah, we have here one, maybe something near the outcrop basement, but this one is the coolest one because you have mentioned the fragile of the deposit, and this is the deposit interpreted as the historic central basin, which is mainly fine sediments or like very much fine mud or sand or mud. So this should be the place that it would be eroded.
Yeah, but as you pointed, even the exposure of bedrock, okay, if the bedrock is exposed in there, it's because there's no sediment on top. So if there was, it was removed, and it cannot get any deeper because bedrock is not erodible.
Yeah.
Right? So it could be interpreted as well as a stratigraphic window in there, caused by these strongest ebb currents that we have today in this in the actual geomorphological stage of evolution of the bay. Okay, so quite glad to see that, Wilson. Very, very glad.
Thanks. This information is really new for me. I haven't seen this before, so it was very nice. Now I'm thinking that it should be something like that was over here, and our lower parts is probably due to this stretch of the width of the bay. Nice.
Well, I wish that you publish that very soon. Then I can use that to broaden up my dialogues about this.
Okay.
It's very good.
It will be published very soon, as soon as possible.
Okay. So I'm quite glad with your answers. You are well-rounded. Okay, and one more time, I congratulate you and the supervisors. Okay, excellent job, and it could move on to a PhD with a little more effort.
Yes.
Okay. Thank you very much, Dan, and I pass the word to Klein.
Okay. Guilherme, thank you very much for your very nice discussion about this ebb and the fluid tidal change in the time, and as well for the change in the morphodynamic of the bay, and for point out just more just process, sediment transport and fluid movement, and that has a consequence in the morphodynamics. Thank you very much. Well, now I will pass the words for Professor Bonetti. It's your time now.
Okay, Klein, let's go. Sorry for keeping my camera off, but considering the huge connections problems we are having today, I think it's better. Okay, I'm grateful to Klein, Michelle, Wilson for inviting me to this jury. It's a really pleasure to be part of this final stage of Wilson's master degree. Hi, and Les, also is a big pleasure to share with you the discussion, excellent level discussion, brilliant. And okay, firstly, I would like to say that I followed, at least in the last year, the Wilson's efforts to complete this work. And I realized that he practically moved this residence to the lock. It's impressive. Whenever I went to the lab, no matter the hour, there he was. It's nice. It's very nice. So I admire his dedication a lot. And I believe the result is, this result is partially realized in this dissertation. But I really believe this is just the beginning of a successful career. Okay, best wishes, Wilson, best wishes. But let's talk about his research, your research. Before, I would like just to remember that I'm here representing the graduate program as an internal member, and I'm less expert in the subject than my colleagues on this jury, and also those who have already collaborated with the elaboration of the paper. So my speech will be shorter, yes. In fact, although you gave us a lot of interesting points to discuss, I chose to focus my question on the results of the sedimentary phases presented in the same figure that return to the figure 6. I'm thinking on the, okay, I have noted on 36. Yes, this is, let's see. The first question is in fact very similar, quite similar to that posed by Professor Hein. I was curious about how were chosen the places to get the vibral cores. You have already explained something, but just confirming, you did not have the seismic results when you got them, okay?
No, the seismic was in a prep phase of the processing, so we already have some thoughts about where we wish to sample with the vibral cores, but we have an issue, which was the column water depth.
Yes, I understand.
Our apparatus that have colored water depth of 2 meters, so we had to choose the shallowest parts. That being our limitation, we choose then the most distant points inside of the bay.
Yes, yes, I understand. Yeah, I ask about this because there is when we are analyzing the figure just below the seismic profile, there is a significant difference in apparent sedimentation rates that could already be identified in the interpretation of seismic profiles. So when you compare the seismic phases and the sedimentary phases, you have a good correlation. It's very nice.
Thanks.
Okay, but about the core E, less already asking about it. Do you have some explanation for the smaller thickness of the unit 4 in score? Or in another way, why we found the unit 3 just few centimeters below the top, just only in this score?
Probably, again, we have the unit 3 as a coarse unit. So unit 4 is a unit that represents our central basin with some benthic lisps that was identified by shells. But again, this is a tidal bank, so these shells maybe was near the bank, not exactly in it. But in unit 3, we also had our tidal delta, but was in a moment of high sea level. So we have this we were talking about. We had stronger tide currents. So maybe that's the motive. We have that coarser sediments in unit 3, but the finer sediment in unit 4 bases. I don't know if I can answer that.
Mm-hmm.
It was the difference in units was done by actually the radiocarbon age.
Mm-hmm.
And also we had the natural gamma ray trend being changing over in this point. So they were the main epochs that we used to define this boundary.
It will be my next question. Okay, but just to return, my first idea, it was about the dredging, because this core is close to the main channel that used to be dredged by San Francisco, the navigation channel in the San Francisco port, isn't
Yes.
it? So I wonder if it's not the part of the superficial sediment is.
I'm sorry, teacher. Your sound is like,
Sorry, Wilson. I will repeat
yes.
slowly, but I understand the problem. I have the same problem with your audio. Okay, so my first idea, it was about the perhaps the part of the superficial sediment package has been removed by dredging, but if you said that it's a tidal bank, I'm not sure about that. So, and you didn't mention anything about dredging in your dissertation. It's okay? Or I missed something?
Okay, first, thinking about the dredging activities, I don't know if it's okay. Okay, it makes sense. But when you have the age data, we have shell in just both the finer sediment with an age of 2,800 years. So it's difficult to have some dredging that time, but
No. no, it's not about that. My question.
I'm
is,
sorry. I'm sorry.
We are talking about thickness of all the unit form.
Oh, okay.
Okay, you have a
difference.
few less than 40 centimeters to the thickness of a unit 4. And why?
Okay.
Maybe the
The
top was eroded or dredged or removed.
Yeah. Now I understand why you mentioned the
Yes,
title.
not about
Yeah.
the bottom of the unit, the top of the unit.
Yeah. Yes. As you mentioned, we have the higher hydrodynamic, so the finer sediments would not be there. But the dredging process that we found the seismic was only in this part of the study. That's mainly in the Bayhead Delta of Cubatão. In some section, maybe I haven't bring in the presentation, but it's over here. Probably this portion was something connected to here, but all this portion is removed by dredging activities as well over here and here.
Okay.
All of this portion is in the zone of Cubatão River Bayhead Delta.
And in the main channel, but there is dredging in the main channel,
Yes.
sure.
Yeah, that's sure. But we couldn't see any signal just clear as we saw over here.
In another curiosity also is the sedimentation rate of this core. It's very different from the
Yes.
others. And just in the beginning, it's not presented here. It's presented in the appendice. You have it's not in your presentation, but you have a very different sedimentation rate at the beginning of closer to the top of the core.
Represent the rate.
No wave sedimentation.
Okay.
I was talking about the by depth, the sedimentation rate at each depth.
Okay. Yes, got it.
Yes, it's just an appendix, but if you see, this is the core more different about this behavior. So something is happening there.
Yes, when we see our profile over here, this one, we can see that our core D is over here, and the color D is the thickest portion of unit 4 that we have in the cores, and this thickness unit is in the Bayhead Delta, that is in front of the Saguaçu Lagoon. So probably it's due to this that we have a high difference in sedimentation rate, which is bigger in this part. And here our which is core E. We have just a little as you can see, we have almost 3,000 years ago dated just in the surface, and even not even 2,000 years in this portion. Probably is due to the morphology of the sediment bodies, because our Bayhead Delta probably had a part of sediment than our tidal bank.
Yes, I agree with you. Okay, but I also ask myself about the beginning, just yet in this core E, the beginning of the unit 2, around 6,000 years BP. It seems to me that it's not in agree with the graphical presented in figure 9, where the unit 2 it's placed between 8. Could you go to figure 9, please? Wonderful, wonderful one. Yes, I love it. And you corrected the order of units because in your dissertation it's inverted. Okay, so the unit 2, it's go around 8 and 10,000 years.
Yes.
And when you see in core E, you place it in around 5, 6, I don't know, because the end of your core is almost. So some explanation?
So let's work with our, let's say, 7,000 years in our inside our unit 2. When come in this part, the unit 2 is the unit 7 probably will be something over here. But now let me explain. We have the difference depth of each unit boundary that I brought in this this position over here, and I use it the depth of each reflector and plotted it in the curve. But sometimes, let's say, unit 2 could be over here and unit 3 could be over here. So I just took the middle point to define its boundaries. But as teacher has mentioned, I could change it to include our data in the segment that are our 7,000. So we could stretch unit 2 over here until at least 7,000. That was the methodology to plot our unit.
Okay. Sure. Okay. Well, another point, returning to figure 6. I will stay just in it. Another point, the last one, okay, Wilson. I couldn't quite understand whether or which sedimentological or geophysical properties were used to establish the boundaries between stratigraphic units along the sediment cores, no? Because, for example, if you see core B shows sedimentological and petrographic variations of the same order as core E. This figure is not the best for see it. The appendix is very nice for this information because you have a better graphical resolution, but okay. Keeping in this figure. The variation between geophysical properties, it's quite the same in core B and core E. But you don't have identified units in core B, unit 3 or unit 2. Although according to the seismic profile, just below in core B, you have the unit 3 there.
Yes.
This unit begins between 1 and 2 meters, so could be represented in the sedimentary cores.
Yes.
No?
Yeah, it could. Actually, this was leads mainly by the ages. So as we have something that was this age is much nearer than this one, we have included in the same unit. But probably this is a question to establish the seismic unconformity. Actually, this reflector probably should be marked below the core. Something that could be maybe the boundary is it should be very. The reflector has too low amplitude, so it's nearly transparent. So also, as you can see, we have over here multiple reflection, and here too. Probably it was masked by the presence of these multiples, so I have mistaken the right position of the unconformity over here. That I can fix it later.
No, I'm not sure. It's just a comment. I think you can discuss it with just nice. Okay. Well, Wilson, bravissimo. Thanks for the answers. In conclusion, everything is okay for me. I really believe you has fully achieved what is expected for a master's degree, or rather, you went beyond. Really, I'm very glad with your work. Thus, I finish congratulating you. You're both supervisors, Michelle, Klein, as well as the other research that who contribute to this result. You have a lot of partners. It's very nice. So thank you very much. Congratulations. Klein, it's with you again. Thank you.
Okay, Carla, thank you very much for your very nice words about the job, about the work, and about Wilson. I agree with you. I'm going to use the same words. Okay. Michelle, it's your time, please. Could you finish this part of the defense?
Okay, thank you, Klein. First of all, I'd like to acknowledge the thesis committee, Chris, and my Brazilian colleagues who I don't see for a long time, years and years, due to many reasons, including the pandemics. So first of all, thank you for your comments and your contribution to the thesis. I must say that if we see the amount of data that Wilson presented, he has much more than a master dissertation. As said by Guilherme, maybe the Babitonga Bay nowadays is the most studied bay, one of the most in Brazil, for sure the most in South and Southeastern Brazil. And I must say also that there is a lot of data that haven't been shown by Wilson. For instance, side scan data. He didn't show, yes, but we do have. There are other data that have been shown, but I am pretty sure that it's not Wilson's duty to do this, because it deserves another work, which are the petrophysical data. I mean the data of magnetic susceptibility, gamma ray, resistivity, and so on. So this deserves another work. Talking a little bit about Wilson, yeah, he has a very big working capacity. He did a great job, especially during these very strange times of pandemics. I am sure that he has bright future, and I would like to congratulate him. I'd like also to thank Klein for the opportunity to work with him, Klein, to work with Wilson, to work with all of these people who were at Babitonga. So I will be very, very brief. Wilson, I hope you continue doing research in Brazil or in any other part of the world. You have a bright future. Keep working. And Klein, once more, thank you very much. And you know that you can count on me. Thank you so much.
Okay, Michel. I thank you. You, Lessa, Hein, and Carla for the great discussion that we have today, and also for the field works and that we did together, Michel, in the Bay with this project. And yeah, I think we had Wilson had a great time today, opportunity to do a very nice discussion with you. And I think, Wilson, do you want to say some words, or we can just finish?
I just want to thank you all for contribution in your work. Formally, I would like to thank you, Professor Klein, Professor Hicks, for guiding me in this project. And I also would like to thank for the collaborators that are not present here now, but this work was done with a lot of head thinking together. It was not one person doing it. So thank you all.
Okay. Wilson, you can turn off the YouTube transmission.
Okay. Bye.
And